Hello there. I'm sitting in a restaurant and I'm thinking if I have a data of customers of this restaurant and how much they are paying on the bill and how much they are paying as a tip and some information about those customers like their gender, whether they are a smoker or not, size of the party size, how many customers eat together. Can I find a pattern and can I say who pays more, whether smokers pay more or non-smokers pay more, and what day the server like waiters get more tip? Can I find some kind of insight in that? Welcome to the world of data exploration. Data exploration is one of the most important steps for any data scientist. Unless you understand your data, you cannot do much with it. And Python provides several libraries for data exploration. Matplotlib and Seaborn are the one which is used the most. In this lecture, I am going to take you through the Seaborn library. So let's say data exploration using Seaborn. Let's import the libraries. Of course, the first library is going to be pandas as pd and import Seaborn as snp, and let's import numpy as np. Three main libraries. These are bread and butter of any data scientist. Next, we are going to import the dataset. Mostly every library like Seaborn as a library, as a Python library, provide their own dataset for testing purpose. We are going to import dataset called tips from Seaborn. Let's say tips equals sns dot load dataset and the dataset name is tips. And next we are going to create pandas data frame for this data set. This you already know, data frame, and we'll put tips here. And let us see the first few rows of the data. We are good to go. So far so good. Okay, let's run it. SNS, oh yep, this should be SNS. Okay, so here you go. This is the data set we are going to work on. A very simple data set. It shows the tip paid, total bill amount, sex, male or female, and whether the person who paid this total bill amount and tip amount in restaurant was a smoker or not, what day it was, Saturday, Sunday, Monday, and what time it was. Was it a lunch, dinner, what time it was, and what was the party size, 2, 3, 4, 5. Okay, so very simple data set. Let's see how much data is there in this data set. So df dot shape is going to show us the data set. So there are 244 rows and of course there are 7 columns. Not very big. Now we got this data. This is very easy to understand what kind of data it is. But when you are a data scientist and you are going to predict tip, then it is not just looking at this data and saying, okay, now I understand that. You need to understand the behavior of the data, the distribution of the data, and how tip is affected by total bill amount or by a smoker or by day of the week or by time, whether it is lunch or dinner or size of the party. These things you have to understand, and this understanding these aspects of data is called data exploration, and that's where Seaborn comes handy. So very first thing you need to do in such cases is understand the distribution of the data, and to do that you need to plot the distribution graph. Just say sns dot dist plot and just say df So let's consider the whole objective of this exercise is we want to predict the tip based on certain other variables. So our target variable is tip, and there are certain features dependent variables like bill amount, sex, smoker, yes or no, what day it is, time and size. So first thing I'm going to do is understand the distribution of the tip in this data set, whether it is normal distribution or it is not normal distribution. Let's run this command, and here you go. This is the distribution of tip data, and it looks like a normal distribution. If you see a bell curve like this, it is a normal distribution more or less. Okay, so let's move on. Next, I am going to understand which of these variables affect the tip amount the most. And to understand that, the best thing is what is called heat map. So next we are going to draw heat map. But before we draw the heat map, we have to first make sure these things are correlated. And so command for that is correlated matrix equals df dot correlated, and next we are going to create heat map on this correlated matrix. Okay, heat map core matrix, and that's it. So this is the heat map. It is not looking very informative because it's missing the numbers here. To add the numbers, we will say anot equals true, and here you go. Now it has numbers. Look at the tip, and down here you see, of course, tip to tip will be 1. They are directly related to each other. But among total bill and size, you can see the total bill amount affects the tip more than size. And why did we not get other variables like this is smoker, day, time and all? Because these are categorical variable. When you do the data scientist analysis on this data, the first thing you will do is you will convert this categorical variable into numerical variables. When you actually do such kind of analysis on this data, all of this column will be numbers. That's why they are not coming here. But the point is, when you do the heat map analysis, you will understand your target variable is affected the most by which feature value, or you can say independent variable, and in this case it looks like the total bill is affecting more than the size. Got it? So we got two information about our data so far, that is a normal distribution and the total bill amount affects the tip more than the size of the part. Very good. So far so good. We are going to create more visualizations, and that will give us more insight to the data. So next visualization we are going to create is a plot sns dot rel plot, and over here we are going to provide our x-axis is going to be total bill, y-axis is going to be tip, and our data is df. Very simple. Okay, and over here. Very good. So we got the plot of total bill versus tip, but it's not very clear. I mean, it's not very informative. Let's add some more criteria to get a proper information. We're going to add color equals time. Okay, let's see. Here we go. Now we got two plots based on the time, whether it is lunch time or dinner time. Good. Let's add some more. Now say who equals a smoker. We will have more information based on whether the person was a smoker or not. Okay, now we got different colors based on a smoker, yes or no. We see a pattern. I see a linear pattern here in both the cases. So far so good. Let's add size also. The size of these dots here, it will be bigger or smaller based on the next criteria we mention. And here we can mention the criteria as size. We have a column here, right? So based on the party size, we will see the different sizes of the dots here. And here you go. The bigger the party size, the bigger the dots here. So based on this graph, now I understand it's a linear pattern. As the total bill increases, the tip amount increases. And there are some patterns related to whether the person is a smoker or not. But we could not make out much here. To understand that part, let's enhance and let us create a regression line based on the criteria whether it was a smoker or not. And to do that, let's say sns.rm plot, and once again we will start with x is total bill Very good. Y equals tip and data equals df. Let's run it. Okay, so there is a linear regression that we already knew, right? We need some more information. Let's add those criteria again. COL equals time. So we will have two graphs now based on the time of the day. And over here, okay, we got two graphs, lunch and dinner, and again it shows the same behavior whether it is lunch or dinner. It's a linear regression. I want to understand if there is a difference in behavior based on whether the person was a smoker or not. Let's add this. Haha, now I get that. Let's look at this. So the blue one is a smoker person and the orange one here is non-smoker. And there is a pattern. The person who smoke, if the bill amount is less, he gives relatively more tip. But as the bill amount increases, the tip given by smoker reduces compared to the person who is not smoking. So now we got a very good insight in this data based on whether the person is a smoker or not. So far we understood normal distribution, the tip amount is more based on the total bill, and now we understand that if the bill amount is high, it's better to serve non-smoker if you are looking for a good tip. Let's move on. Let's add some more visualization, and this time we are going to draw something called cat plot. We understood that there is a difference in behavior. Is there a difference in behavior in the tip amount based on the day of the week? To understand that, let's draw a different kind of chart. Let's say x equal to day and y equals tip and data equals df. Let's run this. It's not finished, but let's run it. Over here we got something. It's not very clean, so let's put kind. So in cat plot, kind plays a very important role, and for here I'm going to say kind is sum. Do you see a pattern now? This tells me that on Friday there is less number of people coming in and the tip amount is not that high, but on Thursday the range of people who are giving $2 tip, for example, that is high. On Saturday that goes a little up, but the tip amount increases, like maybe a lot of people are coming on Saturday, and Sunday also a lot of people coming. One more insight we got. These are the kind of analysis we can get depending on different kind of graph. As I said, the cat plot, this kind here plays a very important role. I can change the kind to violin, for example, here, and it will look different over here. So same kind of information, but it's a different shape. But likewise, I can change this to bar and it will show a different bar kind of chart. Seaborn is a very good library when it comes to data exploration. There are several such methods available using which you can visualize your data and you can get insight into it. So before you start applying algorithm and training your model and all, this helps you understand the data. Before I finish, if you just go and Google here Seaborn Python library, this is the site for that library, and some of the examples I have shown here was from this site, and you can go and explore further. There are very good examples here. That was about Seaborn library and how you can explore your data using that library. I will see you in next lecture.